Hello, dear student. Welcome to this particular class. In this particular class, we are going to understand magnet about the magnet. So we are going to unlock the mystery of magnet in this particular class. Outcome of this particular class will be magnetic and non-magnetic substances. We will be looking on to properties of magnetic substances, characteristic of magnetic substances, and understanding magnetic field. And then finally, understanding Earth as a big magnet. So let's begin. The very first question I would like to ask you, what first comes in your mind when you think of a magnet? Pause this particular video and think about it. Probably you are thinking about an object which attracts other magnet or iron object or repel other magnet. So you are partially true. Let's have a little scientific definition of what a magnet is. So a magnet is a material or an object that produces a magnetic field and can exert a force of attraction and also for the force of repulsion to a magnetic material like iron, nickel, and cobalt. So you might have observed there are in the magnet have two poles. We call it north or south pole. Like pole repel while the unlike pole attracts, meaning north and north or south. They are like, they will repel, and north and south, they are alike, they will attract each other. Magnetic force is strongest at the. So we will be understanding these particular thing in few after some time later. So let's understand a mysterious question that why do magnet attracts? What actually happens inside that particular magnet? We are looking onto the molecular level. What exactly happens on the molecular level and why the magnet attracts? So you know every material is made up of atom, right? Atom has electron and you know electron has rotation and spinning. Two kind of motion in the this particular electron. Due to the continuous rotation and spin of electron, they possess what we call the magnetic domain. So magnetic domain is basically a tiny magnet inside any material. So when these particular type of magnet combines together, their power multiplies or adds. So they become a powerful magnet. But now you can ask question that if every material is made up of atom, an atom has electrons due to the rotation of electrons, the magnet rotation of electron, it behaves like a bar magnet. So why not every object is a magnet? So the answer lies on the alignment of these particular bar magnet, these particular domains. If the domains are aligned in a specific way, if they are pointing outside the material, we call it this particular pole is a north pole, and if they are pointing inward the material, we call this particular pole is a south pole. And if all these magnetic domain you see in this particular pictures are aligned in a same way, in this particular way, pointing in one particular end outside and in one particular end inside, so only then the object will become magnet. If the alignment of these tiny things we call domain is not like this, that is random, so the object will not behave like a magnet. We will be understanding the attraction of magnet in little bit detail and stepwise. So why do magnet attracts? Magnet has, first of all, magnet is made up of copper, nickel, and iron. Normally, so it contains electron. Due to that electron, they have domain, and domain have different direction in any random object. When it comes to the magnet, the magnetic domains are aligned in one particular direction. You can refer to this particular picture for the alignment of the domains. Thereafter, it becomes magnetic domain. One important thing you can note down here is that we call every magnetic object has two pole, north pole and south pole, but this is for the convention. I mean, we can have called this particular pole north instead of south and this particular pole south instead of north. But we choose this particular pole north or this particular pole south, and this is by convention. The same way we walk on the left side. We drive the car on the left side of the car. There is no scientific phenomenon associated with that. In the same way, we call this particular pole is a magnetic pole. Now let's understand step by step why do magnet attracts. So the first thing we know every material is made up of atoms and atom has electron, electron has rotation and spin. So due to the electronic spin, they create a tiny magnetic field and this particular magnetic field is called magnetic domain. If the object has unpaired electrons, it will become a tiny magnet. And if it has paired electron, so the total magnetic movement will get cancelled out. And also the magnetic attraction depends upon the alignment. Okay, so some are atom with the unpaired electron like ferrous, cobalt. Ferrous means iron, cobalt and nickel have unpaired electrons, and due to that unpaired electron they have a spin and rotation. Due to that they form a magnetic domain, and that particular magnetic domain is a tiny magnet inside the magnet. And if they have an alignment in one particular direction, the object is definitely good for to be a magnet. Third thing is magnetic domain. So this is the cluster of atom, or we can say atom consisting of electron and millions of atoms aligned together, and they form what we call a domain. Domain is a smaller magnet inside that magnet. And these particular magnetic domains aligned in a specific way, and their power adds or multiply, then object become a heavy magnet. Right? So I hope you have understood what is the magnetic, how does the object attract other magnetic or non-magnetic object. We have understood how a magnet will attract other magnet. We haven't understood how a magnet attracts the iron or the ferrous substances. So how a magnet attracts the iron and ferrous substances. So if this is a magnet, if this is a magnet and here we have put a ferrous substance like iron. So what actually happens? This particular ferrous substance when come in contact with this particular magnet, the magnetic domain which are their alignment is random initially. When it comes to the contact of magnet, so the alignment of magnetic domains become in a specific way according to the required need of this particular magnet. What do I mean by required magnet? So you see this particular magnet is placed from south to north. So the immediate place which is in contact with the iron object is facing the south place. And you know, for to be one object to attracted by the other object, this particular magnet in this particular position, it must have north pole. And we know what is the direction of magnetic domains in the north pole. They are pointing outside the material. So these particular domains, small domains in aligned and pointing outside the magnet, and now this particular pole become north and this becomes south, opposite of this particular thing. So they will attract each other. So we call it magnetic induction. Due to the presence of this particular bar magnet, the iron object or the ferrous object behaves like, or their magnetic domain aligned in a specific way. So it behaves like a magnet, and hence we call this particular phenomenon is magnetic induction. Now you know why a magnet attracts a magnet, and also you know why a magnet attracts a iron or ferrous substance. Okay, so we have understood how does magnet attracts other magnet and the iron subject or the object of ferrous substances. So if I need to revise, I would say every atom has material is made up of atom. Atom has electrons. Electron has spin, rotation. Due to that, they possess magnetic movement. It is suitable if the object has unpaired electrons, and due to that they form thousands of atoms consisting of electrons with spin and rotation forms a magnetic domain, and these particular magnetic domains, when they are in large number, they also form what we call particular bar magnet. So that is, we have understood how a magnet attracts magnet and other object like ferrous substance. So for magnet to attract the ferrous substance, so it basically induce that particular ferrous substance into a magnetic one. So the magnetism in the ferrous substance will remain as far as the ferrous substance is in contact with the magnet. And as we remove the magnet, the ferrous substance will lose its magnetism. Again, their electromagnetic domain will be aligned, or will be aligned in a random direction. Okay, now we can say that a magnetic field. So what is a magnetic field? If we put a particular magnet and we sprinkle iron filling over this, so the iron particles are aligned in a specific way in the same this spidery like structure, and we call this is magnetic field lines. These field lines essentially indicate the presence of magnetism in one particular magnet. So if we place a magnet over here, so it will get attracted by this magnet, and if we place far behind this particular magnet, far away from this particular magnet, it will be not attracting. A reason, this particular magnet has a limited magnetic field, and these particular magnetic field are denoted by a virtual magnetic lines. What do I mean by virtual magnetic line? So these magnetic line actually do not exist. We can figure them out by sprinkling iron particles, small iron particles or filling, or we can also figure out them by putting an indicating the direction of compass near this particular magnet. So we will put compass over here, and we will indicate the direction of compass needle over there, marking the direction of compass needle over there, marking the direction of compass needle, and so on. So it will give us the the lines, magnetic field line, the direction of magnetic field line. But in reality, these magnetic field lines do not exist, and this you might also have observed that a bar magnet simply looks like a cuboidal shape. It doesn't have this spidery type of network. Okay, so we call it a magnetic field, and it magnetic field has some of the characteristic. Now let's understand. So they also always form a closed loop. They never intersect. So reason for why do they not intersect is that if they are intersecting, what is these particular lines? So these particular lines are basically direction of what? Magnetic domains. So if they intersect, it would essentially mean there are two direction, and there is not possible that a magnet has two direction. If it has two direction or random direction, this will not be a magnetic substance. If you remember the magnetic domain alignment in the initial part. So this is a magnetic domain. They are aligned and they are directing in one particular direction. So inside the particular magnet, they are directing outside the material, and this goes outside that particular magnetic material. They are again directing inside the material. So they form a kind of a closed loop. In this particular magnet, there will be no magnetic field line, as these particular magnetic domains are not directing in one particular direction. And hence, this is not a magnetic object. I hope you understood why the magnetic lines do not intersect each other. Regarding the density, magnetic density basically tells about the field strength. So when the place where these particular magnetic field lines are closer, meaning they are in a high density, that is what we understood a basic definition, basic understanding of density, right? So if these particular magnetic lines are closer, meaning they have high density, and if they have high density, which essentially would denote the high field strength. So they point in this particular north. So they point towards the south direction. From the north, they point outside, and at the south end, they point inside. That is how they form a closed circular loop. So there is no start and or end. So this is a continuous closed loop. Most dense magnetic field lines means high magnetic attraction or high magnetic field. Now let's understand why do magnet repel each other. We have understood why do magnet attracts each other. So the theory for the repulsion is same as for the attraction, for only one twist. Now we know what a magnetic field line. We know it is basically the direction of the magnetic domain inside that particular magnet. So we need not to understand from the electron spinning magnetic domain forming of the magnetic domain. We have understood it. Now we are ready to understand. We are ready with the magnetic field line. So we can understand why magnet repel each other due by the magnetic field lines. So if this is a particular setup where north and south magnetic poles are placed. So if this particular north magnetic pole, which is pointing outside the material, finds the place where the magnetic field lines are pointing inside. So these magnetic field line will each other or uh, overlap each other or get subside. If they find the opposite structure, separate setup of this particular thing, meaning they have north pole, and if these particular north pole magnetic domains direct from outside the material, if they find the same thing, that is also the magnetic line field lines which are directing outside, so there is no possibility they will get overlap. So this they will do not they will not form a continuous kind of a loop, hence they will repel each other. If we still need to understand the repulsion of magnetic field line with the help of magnetic domain, so we can say that, give me a second please. Okay, so if this pointing inside is in south part, so this particular pole or side of a magnet must be which is pointing outside the material. So if this has a magnetic domain which are out pointing outside the material, then only these two substances will attract each other. If this particular magnet has domain which are pointing inside the material, so there is no way that the magnetic field line being produced will subside each other, will overlap each other. So they will basically get repelled. That is what we have understood in the initial time. So like poles are repel and unlike poles attract. What does it mean by like pole repel? So here you see this is magnetic domain pointing inside. So there must be magnetic domain pointing outside. So pointing inside means south, pointing outside means north. So this is north-south combination, unlike pole, and hence they will attract. And if the setup is this is pointing inside meaning south, and this is also becomes pointing inside, south and south, they will become like and they will repel each other. I hope you understand why do magnet attracts as well as why do magnet repel. Okay. So what is basically iron? Magnetic substances are made up of. So they are made up of iron, nickel, and cobalt primarily. So there might be some of other substances, but these are the primary substances or elements of which the magnet is made up of. There are non-magnetic substances. The basic definition would be the substances who don't attract other magnet would be non-magnetic substances like wood, plastic, rubber. Type of magnet. So this type or classification is based on the shape of magnet. So if it is a cuboidal shape, we call it a bar magnet. If it is like this shape, we call it a horseshoe magnet. This is called a ring magnet. This is called a disk type of magnet, similar to the disk. This is called cylindrical magnet, and this is called spherical magnet. From this particular sphere, you might have remember that you might recall that our Earth is also approximate sphere, right? Geoid shape the Earth actually have, but it is, we can say, average or approximately a sphere shape. If you can make a magnet in a spherical shape, then the question comes, why does it possible that our Earth also be a magnet, can also be a magnet? So the answer is yes. So here you can also take a little glimpse of the magnetic substances, their characteristic and properties. I have discussed all of them. You can read one by one. So let's understand what are the prerequisite condition for any substance to be a magnet. So we know that any substance to be a magnet, it must be material, and everything is material, and it must have atom. Every substance has atom. Atom has electron. It is true for also all the substances, and better if the substance is unpaired. So some of the substances are unpaired also, and these particular unpaired substances has rotation and spin. Due to that, they form a magnetic domain. And if this particular part is important, if the alignment of these particular magnetic domain is in a specific way, as we have seen in case of magnet, in a specific way, then only the substance or the object will be magnet. So these are the prerequisite condition. The material must can contain magnetic atom like iron, nickel, and cobalt. Do our Earth consist of iron, nickel, cobalt? The answer is yes. Actually, iron, nickel, cobalt is only coming from the Earth. It should have magnetic domain inside it, meaning it must have atom, it must have electrons, unpaired would be preferred, and must have rotation and spin. Due to that, they form a magnetic domain. So if Earth is made up of material, so it must have electron and it must have magnetic domain. The magnetic domain must be able to move and align in same direction. The material allow easy alignment of the domain when an external magnetic or current is applied. So these two characteristics also satisfied by the Earth. And yes, the Earth has some of the element or atom which has unpaired electron. The material must be ferromagnetic. Ferromagnetic essentially means being attracted by magnet. It must be able to retain the magnetic property, that is permanent magnet, and the ability to lose the magnetism, that is temporary magnet. The Earth as also have this particular magnetic property. Why? Because it has different element which are permanent magnet, paramagnet, ferromagnet, etc. So from here we can say Earth uh, satisfy all the prerequisite conditions for any material to be a magnet. So we can say that our Earth is also a magnet. Why Earth is a magnet? Because of the molten iron in the outer core. Deep inside the Earth, there is a layer called outer core. It is made up of the molten liquid, iron and nickel. And these metal can move continuously, able to heat. Moving metals create an electronic current, and when molten iron moves, it produces electric current. These current generates a magnetic field. Hence, the Earth behaves like a big bar giant magnet. So it has north magnetic pole and it has south magnetic pole. But remember, these north or south magnetic pole has nothing to do with the geographical north and south pole. So you see the upward side of the globe is, we have identified or denoted it by magnetic north pole, but it is not magnetic north pole. Please do remember this. So we have understood there are enough, all the Earth possesses all the characteristics. So hence Earth can be said as the magnetic, a giant magnet. So how permanent magnets are made? So to make any object permanent magnet, So we have to select particular object, and it must be made up of iron, nickel, and cobalt, or their special alloys like neodymium iron boron. Abbreviationally, we call it NdFeB. So we have chosen the magnet material. Now material is placed in a very strong magnetic field. And why we are placing this into a very strong magnetic field? So that the magnetic domain inside that particular material must be can aligned according to the need of the magnet. The force inside the domain aligned in that particular direction, and if the magnetic domains are aligned in a specific way, it is absolutely ready to be a magnet, right? So here are some of the example. So from here you can state a definition. A permanent magnet keeps its magnetism for a long time, even when the external magnetic field is removed. Example are bar magnet, horseshoe magnet, etc., etc. We have understood some of them in the initial time. So properties, it has a strong magnetism, hard to demagnetize, and it remain its magnetism for a longer time, made from of some of the magnetic material like iron, ferrous substances, or cobalt. What are the use of the permanent magnet? So you see a compass is made up of magnet, speakers, earphone, motors, generators, fridge, door, magnetic locks, MRI machine. MRI stands for magnetic resonance. So if you have ever had the MRI scan, so you might have observed the big rotating machine. So due to the continuous rotation, it produce heavy magnetic field. And there are some of the toys which also uses magnetic material. So what are temporary magnet? So iron is a good example of a temporary magnet. When we place the iron in contact with the magnet, it behaves like a magnet. And when we place that iron far away from the magnet, it loses its magnet. It is a very good example of permanent temporary magnet. If we need to say this in a little bit detail or scientifically, so then we can say an object who has the ability to align their magnetic domain when they are in contact with the heavy magnet. And again, the magnetic domain get aligned in the random direction when they are not in contact with the magnets. That's why it is a temporary magnet. So you can remember some of the temporary magnet example, like iron is famous of them. What are the uses of the temporary magnet? So electromagnet in the crane. We can also make temporary magnet by applying electricity. How does this happen? So you know how magnet works. Why do magnet attracts? So when we give a charge to a conducting wire, it also behaves like a magnet. Now you know then how this particular thing will attract each other. So giving electricity to any conducting wire, it behaves like a magnet. Now you know the working of the magnet. How does it attracts? So it becomes a magnet. So it is used in electromagnetic cranes. So we give it electricity to become magnet. We cut off the electricity, it loses its magnetism. So we magnetize this particular substance. We attract the heavy iron object like R, and we displace it to the place, and when we cut off the electricity, so this we got an advantage that we can make the substance magnet when we need it. So in the electric bells, switches, transformer, magnetic door holders, and motors are the some of the things which uses temporary magnet. Basically we can say electromagnet. So I have told you how the electromagnet are formed. Basically when a conducting wire, electricity flows through a conducting wire, it behaves like a magnet. When it behaves like a magnet, you know how this attract other magnetic objects. So there is also care and storage of magnetic so that it would not lose its magnetism. We have to take care of some of the things, like we should not drop or hit, otherwise it will lose magnetism. We should keep from this particular object from magnetic object from the moisture, etc. Now let's understand demagnetization. So how demagnetization happens? So there are three methods by which we can demagnetize a substance. So demagnetizing by heating. So how this happen? You know, every object has magnetic domain. Now you are comfortable with the magnetic domain. So we can start from the magnetic domain. We need not to go so much deeper like on the electronic scale. We are comfortable with the magnetic domain now. So every object has magnetic domain. When we give it heat, electricity. So due to that heat, the particles inside the magnet get a kinetic energy, and due to that they have random orientation or random alignment. And if we cut off the heat source, so the random would end in a the magnetic domains uh, alignment would end in the random direction. So it would lose the permanent magnetism, and it would become a temporary magnet, a permanent non-magnet substance. Basically, we give heat. The particles inside the magnetic iron get kinetic energy. Due to that, they lose their alignment. And you know, if object loses its alignment, it is no more a magnet, right? Demagnetization by hammering. If we hammer any object, so it also gives, so the alignment of the domain inside that particular material is distorted. So the alignment becomes in any random direction. You know, the alignment become a random, magnet lose its magnetism. The important thing is magnetic by third important demagnetization method is electricity. We give electricity, so the magnet loses its magnetism. The magnet is placed inside a solenoid. Solenoid is basically coil of wire, and the solenoid is connected to the AC power supply. And AC power supply is continuously changing its direction. If you have little glimpse of AC power graph, so it is like a wave. So it changes its direction 50 times per second. So this is above 50 seconds, and this is in a half second, and this is below that particular graph for a half second. In one complete second, it gives positive half and negative half. If you have remember the graph, that's why we call it alternating current. If you are on observing this from the positive of the x-axis, we will only see positive half, and we will see the blank portion. Due to that, this particular continuous changing direction, the magnetic domain also aligned in the same way. That's why the magnet become magnet demagnetized. So we have understood what a magnet is, and how what by of which material a magnet is made up of. Why do magnet attracts? Characteristic magnetic field and magnetic field line of a magnet. Electromagnets. Earth has a big magnet, and the methods of demagnetizing any substances. So that is it for the today class. I will be seeing you in the very next one. Till then, keep learning and have a great day. Thank you for your attention.